Good morning to all the respected professors, my fellow classmates, and everybody present here. My name is Rohan, Jain, student of BTech 8th semester Mechanical Engineering at University Department, Rajasthan Technical University, Kota. Today I am here to present the topic of my seminar presentation on flying car transportation system under the guidance of Dr. Manish Chaturvedi sir. So let's start with the first slide. These are the contents of today's discussion. First of all, let's try to answer the question, what is FCTS? FCTS stands for Flying Car Transportation System. Compared with existing transportation system, the core advantage of FCTS is the revolutionary step of systematically and commercially exploiting the NGS, near ground space, for the movement of people and goods, although helicopters have already utilized the NGS to some extent. Specifically, FCTS can be operated and organized to provide fast and convenient yet affordable human and freight transfer services for public and private purposes. FCTS are capable of expanding upon current public and private transportation by increasing the traffic load and accelerating the movement of people and goods, especially in urban areas when simultaneously reducing traffic congestion and air pollution. Let's compare among the main transport systems. Here we have compared different transportation systems on the basis of distance objects, that means people or goods, cost, flexibility, load and utilization. First, we need to understand the need of FCTS. When FCTS are implemented, some essential infrastructure for traditional ground-based transportation system such as roads and tunnels can be entirely avoided. Furthermore, electric powered rotors of flying cars can be designed and equipped to dramatically reduce the onboard noise and emission, and thus make the travel experience more comfortable for passengers. Flexible and fast door-to-door transportation is achievable because shorter travel paths can be realized by flying cars that are not obstructed by physical infrastructure, unlike ground-based transportation system. Congestion-free transportation is possibly by benefiting from the underexploited and underlimited NGS resources. Environment-friendly transportation is supported as flying cars equipped with power cells with zero direct discharge and emission can be theoretically achieved. Now talking about the design of flying cars. We would be discussing the design of flying cars in terms of the following four aspects: takeoff and landing TOL modes, pilot modes, operation modes, and power types, which are related to the adaptability, flexibility, comfort, stability and complexity, and environment friendliness of flying cars. Takeoff landing mode, which we generally call as TOL. VTOL. Aerial vehicles can take off and land vertically. Under this mode, no runways are needed for either takeoff or landing, thus giving more choice of potential TOL sites and more freedom to reach passenger anywhere that they wish to go. Next is VTHL, vertical takeoff horizontal landing mode. Aerial vehicles can take off vertically but return to the ground by taxiing along a runway. Thus, runways are necessary for the landing process, but takeoff is not restricted to the runway. Next is HTVL, horizontal takeoff vertical landing mode. Aerial vehicles taxi along the runway before takeoff and the vertical at the destination. Thus, runways are required for the takeoff process, but there is flexibility for the landing process. The last one is HTOL, horizontal takeoff landing. Aerial vehicles require a runway for both takeoff and landing. This mode is most common mode for fixed wing aircraft, and runways or ground support are always required. Moving on to the next aspect, that is pilot modes. Pilot modes refer to how the flying cars are operated and controlled using TOL and flying, which is most important in terms of hardware cost, operating cost, and the safety of flying cars. Typically, there are three kinds of control modes of flying cars. First one is HP, human piloted, second one is self-piloted, and third is hybrid modes. HP mode. Under this mode, flying cars are operated by pilots as in traditional aircraft, and a driver license or a pilot certificate is required. Thus, labor costs are significant, leading to a considerable burden on the commercial operating of flying cars. Next is SP mode. Under the SP mode, flying cars can perform all the operations in fully autonomous way without the need of four pilots, thus incurring lower operating costs than HP mode. The HP mode benefits from the maturity of the technology surrounding autonomous control and navigation, that is making SP vehicles smarter and safer. Moreover, in the future, artificial intelligence technologies will be more reliable and efficient. The last mode is hybrid mode. The hybrid mode has been proposed and adopted by some flying cars under the development to take full advantage of the individual benefits of two control modes. Although the manufacturing cost of flying cars with the hybrid mode are higher than the cost of two other modes, the hybrid mode is still the best candidate for the certain application such as flexible transportation without fixed routes. Next aspect of designing flying car will be operating modes. Because various kinds of TOL modes, types of wings exist, flying cars can be endowed with different operating modes such as airplane, helicopter and hybrid modes. Airplane mode, only two flying car prototype is in development, operates in traditional airplanes. For example, the heavy side can take off, fly and land like traditional airplanes but cannot travel on road like cars. Therefore, considerable space is required for the TOL of this kind of flying cars, making it suitable for urban areas. Next is helicopter mode. The helicopter mode is a popular operation mode of flying cars which fully inherits the TOL and flying characteristic of helicopter. Thanks to the unique TOL procedure of helicopter mode that does not require a runway and thus can save a lot of space, flying cars with the mode are quite suitable for transportation in urban areas. The last mode is hybrid mode. To satisfy different application demands, designers have also presented some other hybrid modes that combine the advantages of individual operating modes like helicopter car mode, helicopter airplane mode, airplane mode. So, talking about the brief helicopter car mode, under this mode flying cars can take off, fly and land like helicopters and also travel on roads like traditional cars. Generally, this kind of flying cars is equipped with foldable rotary wings. Next one is helicopter airplane mode. Under this mode, flying cars take off and land like helicopter and fly like airplanes. The main difference between helicopter airplane mode and helicopter mode is fixed foldable wings and horizontal propellers. The third one is airplane car mode. Foldable wings are employed by this kind of flying cars to improve both flying performance in the air and running performance on the road. The flying cars can taxi on regular roads for takeoff and landing. Because of the space requirements of TOL mode, the flying cars and the airplane mode are not usually suitable for urban areas. Next aspect for designing is power types. Depending on the application purposes, there are three main power types for flying cars: electric power, hydrocarbon fuel and hybrid power. Electric propulsion is widely the preferable propulsion method for flying cars because it has many desirable characteristics such as lower emission and less noise pollution. Electric batteries are the preferably energy source for flying cars in urban areas. Next one, hydrocarbon fuel. Some flying cars designs use hydrocarbon fuel and combine the advantages of traditional cars and aircraft by enabling flying cars to travel on the ground like traditional automobiles and to fly in the air like aeroplanes. However, the hardware cost and the manufacturing complexity of flying cars that are powered by hydrocarbon fuel are sustainably lower than the flying cars that use hybrid power. The last one is hybrid power. Electrically power outperforms hydrocarbon fuel in terms of reduced emission, noise, hardware complexity, weight, and increased energy efficiency. However, the durability and refueling speeds of hydrocarbon fuel are superior to electric power, making hydrocarbon fuel more suitable for long distance transportation design. Thus, we can conclude that while electric power is the greenest and most cost-saving power configuration for flying cars, and hybrid power is more reasonable commercial choice for hybrid transportation, especially over long distances. After discussing about the design of car, we should definitely discuss the design of transportation system. So defining the FCTS in terms of following three aspects: path trajectory planning, supporting facilities and commercial designs, which are key problems encountered in the large scale operation of FCTS. The first one is path trajectory planning. It is a crucial issue in the field of FCTS. Indeed, flying cars are mainly designed to operate in urban areas to ultimately achieve shorter transportation times and relieve road congestion. However, the higher operating speeds in air may cause collisions and consequent chaos among the flying cars and buildings. Position and navigation. During the flight process, the most important thing for a flying car following a pre-designed path is accurate positioning and navigation. Therefore, achieving precise information on the position and navigation is essential. Radars are an effective tool for ground control centers. Accurate positioning can be achieved by using new position and navigation algorithms that adopt some reference nodes. Object of path trajectory planning. The purpose of path or trajectory planning for FCTS is to generate 3D geometric paths for an initial to a final destination point, passing through predefined through points either in restricted spaces identified government or in wildlife conservation areas. Next, 2 points are fixed path planning for public transport in urban areas in which passenger flows are relatively stable. It is commercially viable to provide fixed path for flying cars similar to the ground-based public bus transportation system. Next is adaptive path planning. Besides public transportation discussed above, there are also some other application scenarios for the flying cars in which transportation requirements are dynamic, such as short distance travel and sightseeing and customized personalized services. Some few aspects to define FCTS would be support facilities. Similar to traditional ground traffic systems, some support facilities are essential to set up and maintain efficient services of flying cars. Generally, in terms of these different functions, the support facilities of FCTS can be divided into following: communication systems, TOL sites, storage and maintenance facilities, that is known as SMF. Communication systems. Communication systems are crucial for FCTS, which serve as central nervous system that collects, delivers, switches, and broadcasts information between flying cars, control centers, and information service providers. There are two kinds of communication systems are nearly to supply FCTS and passenger with control information and data communication services, respectively, as discussed below. Control signal system. The control signal system for FCTS ensures the efficient organization of flying transportation allowing flying cars from all participating companies to provide high quality services as well as profiting from the services. The key goals of the control signal systems for FCTS can be summarized as the efficient and intelligent management of public personal transportation, the optimization of traffic flows leading to better passenger experience, integration with other public transportation systems, the promotion of utilization of FCTS by making it more attractive. Next point is data communication system. The purpose of the data communication system for FCTS is to provide normal voice and multimedia data communication for passenger, which is an essential part of FCTS to enhance the passenger experience during the transportation system. The key requirement of data communication system for FCTS is that it be reliable, seamless, robust, and provide high-speed data transmission. TOL sites. As FCTS are able to provide direct point-to-point transportation services, the location and construction of TOL sites should enhance the attractiveness and associated ridership of FCTS by providing high-quality services and experience to guarantee efficient mobility for all riders within the service area, especially in urban areas. The points are access coverage, mobility, and SMF. SMF, although no roads or tracks are required for FCTS, some necessary supporting facilities are required to run FCTS, such as SMF. There are generally two kinds of SMF related to the unique properties of FCTS and function of the facilities: specialized SMF and temporary SMF. Specialized SMF is tailored to provide daily storage and maintenance for flying cars and should be large enough to accommodate all flying cars in a service area. Temporary SMF is designed and integrated with normal TOL sites to supply temporary storage and maintenance service for the flying cars that are temporarily out of order. Next point is commercial design. Because FCTS is a novel transportation method, commercial operation modes must be proposed and designed to outline the commercial viability of FCTS in the real market. In the following section, we will describe the commercial design of FCTS considering two aspects: market opportunities and commercial methods. The primary market opportunities of FCTS are related to its ability to relieve the pressure caused by increasing congestion and overcrowding in cities that has been brought about by rapid urban development and increase in urban populations. Specifically, FCTS is capable of satisfying the main requirements of urban mobility and transportation in cities, which can be loosely categorized into human and freight transportation, while taking the pressure off roads and other infrastructure and reducing transportation costs. Commercial model includes the commercial model of FCTS outlines how FCTS can be implemented in the real market. In general, there are two potential types of commercial models for FCTS according to commercial operation behaviors. They are public transport mode and specific transport mode. Now moving to the challenges of FCTS, although several flying cars prototypes have been already proposed and manufactured and tested, achieving the large-scale practical commercial application of FCTS is still some distance off. Considerable challenges remain, not only technical aspects but also specific commercial and ethical issues. Safety issues may be listed as follows: passenger protection, robustness of weather, collision obstacle avoidance, search and rescue, noise suppression. Some commercial issues are manufacturing cost, pilot training and hiring, commercial license application. The other ethical issues related to FCTS would be disturbance to human ecosystem, invasion of human privacy, environmental pollution. Environmental pollution can be divided into two parts, which can be caused by batteries. Battery production causes more environmental damage besides carbon emission alone, and used batteries contain numerous toxic heavy metals. New technologies for green battery production and advanced recycling technique for waste batteries are required. The another one is emission during electricity generation. Although renewable resources is the fastest growing energy source, 76% of all electricity on the grid across the world was generated by traditional fossil fuels, including petroleum, natural gas, or coal. Therefore, the preferable energy source for FCTS of power batteries is still indirectly consumes considerable hydrocarbon fuels. With that, we can draw the following conclusions. Emergency mechanisms must be provided and safety equipment must be installed on flying cars, as the safety of passengers is absolute priority for the commercialization of flying cars. The next conclusion is a collision obstacle avoidance mechanism must be designed for FCTS, while a search rescue program must be predefined for FCTS if it is commercialized. VOTL and electric power are necessary for flying cars operating in urban areas to adapt space-constrained urban areas and improve environmental friendliness. The another conclusion is autonomous pilot is the best choice for flying cars operating along fixed lines and time schedules, similarly to public bus and train services, due to the saved operational cost without using a human pilot. The last conclusion is more effort must be made to gather support from investors but from the government to achieve and financial and policy support respectively, and to guarantee the successful commercialization of the FCTS in the future. Now let's head towards the question answer session. I would be glad to answer your question if you have any.
Will there be flying cars in India soon?
Asia's first hybrid car can accommodate 2 people at a time and feature doors that open upright like wings. The flying car by Viantia Aeromobility is still under development and is expected to become a reality by 2023 or 2025 in India. Thank you.